Many of our circuits use aerial cable systems. You may know them as Hendrix cable or spacer cable, where the actual power conductors are covered in an insulating jacket. That covering is a genuinely good thing. It means the wire can tolerate a branch brushing against it without causing a fault, which is why these systems need less clearance along most of the span than a traditional bare wire does. Here's the important distinction. That reduced clearance rule only applies to the covered wire itself. At the pole, where the cable connects to hardware, that protection disappears. The connection and the equipment there are exposed and energized, just like on any bare-wired pole. It's an easy detail to lose track of if you're used to these systems being more forgiving along the span. Today, we're going to cover what these cable systems actually are, exactly what stays exposed at the pole, and what you need to trim for. What is an aerial cable system? An aerial cable system, commonly called Hendrix cable after one of the major manufacturers, is built from three components: covered conductors, the actual power-carrying wires, wrapped in layers of insulating polymer material, a messenger wire, a separate, bare grounding cable that carries the physical weight of the whole system and keeps it strung between poles, and spacers, small insulated brackets spaced along the span that hold the three covered conductors in a fixed, compact triangle position relative to the messenger. What's actually exposed? Here's what to specifically look for at every pole where an aerial cable system connects. Crossarms, where the cable attaches or is dead-ended. The crossarm hardware itself is bare metal, and a branch resting against it is resting against energized equipment. Insulators and connectors. The point where the covered conductor's jacket ends and it clamps into pole hardware is a bare connection point, even though a few feet of wire on either side is insulated. Transformers. Transformer bushings and the connections leading into them are exposed. A transformer sitting close to canopy growth is one of the highest priority checks on this whole list. Cutouts and fuses. These protective devices are mounted with exposed conductive parts and are easy to overlook if your eye is drawn to the covered wire instead of the equipment around it. Dead end and tap hardware. Anywhere a line terminates or splits off to serve a different direction, the hardware at that junction is exposed. The pattern across almost all of these: covered wire in the span, bare hardware at the pole. Train your eye to specifically check the pole itself as its own zone, separate from the span leading into it. What to trim for: clearance and priority. There are really two different standards to apply here, depending on what you're looking at. At the pole, hardware, transformers, and any other exposed equipment, we maintain CCD clearance. Along the aerial cable span itself, the standard is different. Since the conductor is covered, our concern isn't a strict clearance distance, it's making sure no tree or branch is causing strain or abrasion on the cable.
If a tree is causing extreme tension, or bare wire is showing through the covered insulation, then that's a P1. If a tree is deviating the line, then that's a P2. For both these instances, trim the vegetation back to CCD clearance.
So the question changes depending on where you are. At the pole, ask, will the vegetation break CCD clearance? Along the span, ask, is this rubbing or putting weight on the cable? Transformers specifically have their own priority classification, and it splits differently depending on whether you're in a high fire area or not. In a high fire area, a tree touching the bottom half of the transformer is a P2. A tree touching the top half of the transformer is a P172. And a tree touching the top lid of the transformer, or the bushing, is a P1. In a non-high fire area, a tree touching anywhere on the sides or the bottom of the transformer is a P2. A tree touching the top lid or the bushing of the transformer is a P1. So the dividing line moves depending on the area. Be sure to know your fire zone for your circuit when you're checking transformers. And if vegetation is touching, know exactly where the contact is: bottom half, top half, or the top lid or bushings.
All right, y'all, it's Roy. Let's do a quick recap. Now listen, it's like this. When you're patrolling aerial cable, walk the line, eyes on every pole. Don't skip one, 'cause it looks good from the truck. Trim any vegetation around the poles, exposed hardware, and transformers if it'll break CCD clearance. Look for strain or abrasion on the cable. That's it. Simple as pie.